Good day viewers, let's go through this trigonometric diagram together. It says in the diagram point P is given as with coordinates k and 1, and point P lies in the second quadrant and is root 10 units from the origin. So the question states that 5.1.1 wants us to calculate the value of k. So to find the value of k, what we need to do is we need to drop a perpendicular, and what this means is that in terms of the coordinates, what this means is that this point here is k units and is 1 unit above. So we can use Pythagoras theorem to find the value of k. We can say that the square of the hypotenuse, which is OP squared, is equals to x squared plus y squared. So OP squared is root 10 squared is equals to x squared, which is k squared, plus y squared is 1 squared. So square cancel square root, so we have 10 is equals to k squared plus 1 squared is 1, so k squared is equals to 10 minus 1 is 9. So this implies that k should equals to the square root of 9. So this, therefore k should be equals to negative 3 units. So in the place of k, I'm going to substitute negative 3 units, because this is negative 3 in the negative x-axis, so this has to be negative 3. So the second question says, without using a calculator, calculate the value of a negative cos theta. So cos theta by definition is the adjacent side over the hypotenuse side. So this is, we can write it as negative cos theta is equals to negative, and cos theta is adjacent, which is negative 3, over the hypotenuse, which is root 10. So this is equals to 3 root 10. So it's just worth noting that cos theta would therefore be negative 3 root 10, and we might as well just also note sin theta. Sin theta by definition is the opposite side over the hypotenuse, so the opposite being 1 over root 10. So let's see if we can find b. My advice would be first to reduce this expression, because we can use a reduction formula for these two terms here. So let's do that. So we can write this as square root of 1 minus sine of 180 plus theta. Sine is negative in the third quadrant, so this is minus sine of theta into and sine is also negative in the fourth quadrant, so we can write this as negative sine theta. So this can be further simplified to 1 minus negative and negative is positive, so this is sine squared theta, and this here is equals to the square root of cos squared theta, and square root cancels square, so this is cos theta, and we found cos theta earlier on to be negative 3 over root 10 This is equals to negative 3 over root 10. And finally, they want us to show without using a calculator. In other words, we need to prove this identity here. So let's see how we can do that. So if you notice that the expression on the left reminds us a lot of the double angle formula, that is sine of 2 theta is equals to 2 sine theta cos theta. So let's use this knowledge. To prove that the left hand side here is equals to the right hand side. So the first thing that I'm going to do is I'm going to introduce 2. I'm going to multiply 2 on both sides of the equation. So this would give me 2 sine theta over 2 minus 15 degrees cos theta over 2 minus 15 degrees. This is equals to root 3 plus 3 over 2 root 10. So now we can apply the double angle formula on the left hand side. So this can be written as sine 2 into theta over 2 minus 15 degrees. So we can distribute this 2. So this is equals to sine theta minus 30 degrees. So now we can apply the compound angle formula for sine theta. So this looks something like sine theta cos 30 degrees minus cos theta sine 30 degrees. So I want us to take note that sine 30 and cos 30 in this expression are special angles. So now we can just plug and play. So we found sine theta to be 1 over root 10. So we can just plug that in. So this is equals to 1 over root 10 times cos 30 is root 3 over 2, root 3 over 2 minus, we found cos theta to be negative 3 over root 10 into sine 30 is half. So we can just reduce this. So this is the same as, is equals to 2 root 10 root 3 in the numerator minus root 3 over 2 root 10. So if you multiply in, you get root 3 over 2 root 10 plus 3 over 2 root 10. So the denominators are the same, so you add the numerators, 2 root 10 root 3 plus 3. And if you go back to the top, this is what we have here. You can of course divide by 2 to go back to the original. Thank you guys for watching. See you in the next one.